I'm Daniel. I work in the operations group at Puppet Labs. I'm on the team that runs our internal Puppet infrastructure. And coming into the Puppet 4 language, I'm feeling that same excitement again because it adds these language constructs that let you express more logic, that let you move up the stack and think at a higher level. So it's tremendously exciting, and I'm hoping to convey that in the talk. And the takeaway that I want to give everybody is not that you should follow these specific coding patterns or examples, but that you can break out of the way that we're using Puppet and that you can solve problems that previously were possible to solve with Puppet 3. It's Turing complete, so in principle you can do anything, but you have to do some really terrible hacks with inline templates and so on to do fairly basic things that you expect in any programming language. And in Puppet 4, there are native idiomatic ways to do these things. And I'm hoping that we can get more experimentation going, that people will push boundaries and see what we can actually do with this that people don't realize you can do in Puppet at all. Let me get a sense for what the experience levels here are. Who has played with Puppet 4 or future parser? OK, so maybe half-ish of you. How about any CMDB service discovery of any variety? How many of us? Should probably be most of us, I would imagine. OK, so maybe half. PuppetDB in particular. How many of us use that, exported resources, et cetera? And Eric Dalin's PuppetDB query that comes out of Spotify. So maybe a quarter of us. OK, so I'm going to have to give a bit of background about the problems that we face, about what our code base looks like, about what kind of host metadata we track, how we use PuppetDB, because we've been using PuppetDB query more extensively. So I have a little bit of background on that, so you understand both sort of some of the fundamentals of how we're building things on top of that, and some of the rationale of why. So for our code base, we have a sort of a medium-sized code base, about 42,000 lines of Puppet code in the control repo, another 86,000 lines of code coming in through the 143-ish modules that we pull in through our Puppet file. Not a giant number of nodes by the standards of some of the people I've talked to here who run 20,000, but they're classified to 114 roles. So we have a fairly large diversity of services, and that implies a lot of complexity to manage. We also model things fairly extensively, so we end up with between 1,000 and 1,600 resources for most of our nodes, and things like monitoring are like 10 times that, so there are a couple of outliers. Another thing that adds some complexity is that we have a wide range of contributors. So you can imagine that at Puppet, we have a decent number of people who want to contribute some amount of Puppet code. And some of those people are contributing every day. We have 25 people who have contributed more than 1,000 lines of code, and a handful who have done quite a bit more than that. But we have other people from engineering or BizOps who need small changes made, and they don't want to have to do a bunch of work to grok all of those 42,000 lines of code. And to keep them involved, it's important that the code stays readable. And so there's a challenging trade-off between doing interesting things and managing complex systems and making the code base approachable so that we don't end up with a handful of gatekeepers that write all of the Puppet code. And we also merge around 11 commits a day, so it changes fairly quickly. And if you don't understand what the implications of your changes are going to be, it's easy to break stuff or to have your PR just waiting forever. To do service discovery, there's 4 key facts that we track. So we have a fact called group, which is the larger service that that host participates in providing. PL is for the puppetlabs.com web infrastructure, backup, monitoring, that kind of thing, a service that's composed of potentially of several individual applications. The individual application is the next fact, is the function fact. There's some number of those, like you typically would have several web application server nodes. And then there's the stage. So we track dev, stage, prod as a fact rather than using Puppet environments for that, because we use R10K and a branching workflow where we'll create a branch for a feature. And so everything is checked into production, but there are dev and stage nodes, and so that's how we track that. The rationale for that, I think you'll see in a moment, because the way we use PuppetDB isn't just for reporting. We use it for service discovery, and our more recent code very heavily uses PuppetDB query for that, with a heavy reliance on those custom facts to do automatic discovery of peer nodes that either need access or that you need to access. A quick example for those of you who haven't used PuppetDB query, comparing how you would implement the same functionality using exported resources versus PDB query. So say you have an LDAP cluster, and you have an HA proxy load balancer in front of it. Your load balancer is going to have a line very much like this. What actually happens? So you've come into this code base, you're relatively fresh to it. It's kind of hard to anticipate what exact configuration will result. So say LDAP can run regular LDAP on port 389 or LDAP SSL on port 636. You look at this, you don't know what your load balancer is listening on. You don't know if it's doing health checks, if it's just doing simple TCP health checks, or using HA proxies ability to bind to LDAP to verify that it actually works. You don't know if any nodes are even going to show up here if you're configuring an empty load balancer. Using PuppetDB query, it's much more explicit. So what we're doing here is we're asking PuppetDB using this query facts function for nodes that are classified to the class profile open LDAP that are in the same stage, dev stage prod, as the load balancer. And we're asking it for these 4 facts of stage, FQDN, host name, IP address. And then that hash that we get back, we're iterating over and creating resources explicitly so that there's no ambiguity, right? Not like the exported resource collection. There's no possibility for exported resource name conflicts. And if you wanted to refactor this, let's say you don't like HA proxy anymore, the company standardized on F5, and you want to switch this out. If you were using exported resources, you would have to export F5 resources from every node. If you're doing this approach, you can just stand up a new dev node. You can even have it query all your production nodes, your stage nodes, whatever, and you can iterate quickly because you can just swap those resources out and configure your new load balancer and run an experiment to see if it works. And you haven't had to wait for Puppet to run on whatever nodes you're load balancing. So that basic approach of using PDB query and iteration is incredibly powerful and is going to be in most of the examples that I show. One of the problems that I mentioned in both of those approaches is what if you configure an empty load balancer, right? So when I started out using this pattern, I actually took down puppetlabs.com because there was this was working great, and then we accidentally pushed a bunch of empty catalogs for the web servers. So PDB query ran. It returned an empty hash. This ran, and it purged all the backends out of the load balancer, and the website went down. So that was terrible. That was not fun at all. So it turns out you can use the new type system to work around this. So if you look here, what we're saying is that we expect to get back a hash that has strings as keys and hashes as values, and that those hashes have strings as keys and strings as values. And at the end there, we're specifying that there has to be at least one member in that parent hash. Otherwise, the compile will fail. So if there are no balancer members at all in PuppetDB, this compile will fail, the load balancer won't get reconfigured, and the website stays up. Or if somebody, say a new team member comes in and they decide to refactor some of this code, maybe there's a cooler way of doing this, and they don't actually quite understand the code. So first, this helps them understand what I expected to get back when I wrote that. And two, if they change the query so that they get back, say, just an array of strings, this will fail. And they'll get a friendly error message that explains what was expected and what they actually got. So exported resources, there's perfectly valid reasons to use. But if you use PuppetDB query, you get a lot more power. You get more risk, right? You get basically whatever you can dial in, as far as you can get less risk than exported resources. You can get more risk. You can build your own, you can dial in your own level of comfort. There's 4 patterns that I want to go over. And while I was preparing this, I was hesitant to even call them patterns because they're so simple, right? Like you don't want to say, OK, I can map over an array that's a pattern, right? Like that's not really much of a pattern. And I was hesitant to even present it like this. And that conflict was because I was doing a lot of useful stuff with extremely simple programming stuff. And it took me until yesterday to realize that that's actually good, that I can actually do a lot, deliver a lot of value with such trivial programming constructs that I'm hesitant to even tell you guys about it. So the first one is what I'm calling a drop-in service profile, something like Memcache, Redis, a relatively simple service that other things depend on, that you'll compose it together with other things. It's usually configured about the same way, but it needs some amount of context. In this case, just firewall rules, because there's no built-in security. So what you can do with this is you do an include profile memcached from some role. And this will go and it will do a PuppetDB query to find other nodes that are in the same group and the same stage. And we have a custom where am I fact that does some really dumb stuff to figure out what data center you're in. So there's some physical locality here. The point being that then you can iterate over this and create firewall rules so that you don't need to put anything in Hira. You don't need to reconfigure anything. You just drop this thing in, and the nodes that need access have access, and you don't need to think about it. And that simplifies network design because you can have a fairly flat topology. You don't have to specify subnets for these things ahead of time. Like our AWS VPC is totally flat. We just use this sort of an approach and punch firewall holes for every single node. And you can do the same thing, by the way, using the AWS module. You can actually punch those holes in AWS security groups. So you can do this with a lot of services. Here's kind of a simple example of an NFS export defined type. It's basically the same thing. So you're saying I have a dub right at the bottom there. I have a dub folder on my NFS server that I want to export, and I want it to have access from all the nodes that are a role web server. So this does a PuppetDB query, and it finds those nodes. It generates the export, the /exports file, or adds a concat for that, adds a firewall rule so that that host can get through. And you can use this without really thinking very much in a very declarative way, and PuppetDB discovers everything for you. You could do this with exported resources, but troubleshooting it is really painful. And adding something like this onto an existing system is possible here without having to coordinate with other service owners. If you have organizational boundaries that are crossed when you have to modify some parts of your code, this is much faster. So this actually works for more complex services too. So Eric and Ryan at the front here will remember what, a month ago, 2 months ago, we came back from Monitorama and we're super gung-ho about Kafka. Everybody's talking about Kafka. Well, cool. On one of our Friday hack sessions, we sat down and wanted to stand up some Kafka. And Kafka has a Zookeeper dependency, and people complain about Zookeeper being complicated. But it so happens that we had a profile like this for Zookeeper. So we pretty much did an include profile Zookeeper, and then went on with building one for Kafka. And it was a non-issue. Like, it just stood up. It was the same experience people talk about with just pushing a Docker container out somewhere. But all the discovery happened. Those nodes just bootstrapped. It found itself. It makes it really easy to build new services. So that was extremely rewarding, because the work that we had done for a totally unrelated service, for Mesos, I think it was, we could just reuse. The second pattern is patterns are around some distributed systems bootstrap stuff, like Zookeeper. So one of the frustrating things with a distributed system and Puppet is you have these order dependencies, right? And you have bootstrap problems. So the dumb way is to specify everything in Hira. You just hard code all the values. If one node needs to be a master, another a slave, you just hard code that. And that's a valid approach. That is the conservative approach. If you do that, I'm not saying you should necessarily throw that out, because it's very predictable. It's also not very easy to iterate on. So we've found some approaches using Future Parser, using PuppetDB query to improve our ability to stand up those kinds of clusters quickly. And frankly, to accept a little bit more risk in exchange for that flexibility. So one of those that I have a code example for is deferring management of some of those resources until you reach a quorum. So let's say we have a new magic service called Supercluster here. And Supercluster will not be happy if each of the nodes comes up at totally different times when the other nodes aren't ready for it yet. So you just do a PDB query, and you look for what other nodes exist that are classified the same way. And if you haven't reached your quorum yet, you don't bail, because then you can't bootstrap. You just don't manage those resources. And then once your quorum of nodes is up, then they all get configured at the same time. So this is a relatively simple example, but you can layer several of these together to build sort of stages. So in the OpenStack work that Richard has done in our ops team, he uses several of these together to, for example, configure all the firewall rules before trying to bootstrap a Galera cluster, so that by the time that bootstrap happens, all those nodes already have firewall holes punched. And you're following the same pattern, right? You're just looking first for nodes that exist at all and building firewall rules. And once all those nodes have been successfully classified with firewall rules, you move ahead and do the next thing. You just compose these things together. Is this kind of making sense so far? Are there any points of clarification you'd all like before I move on? Cool. I assume that means perfect understanding. Another thing we've been doing with this is some really basic work placement. So when we started moving stuff into AWS, the best practice is to have your stuff across multiple availability zones. And I started using the Puppet Labs AWS module to create those nodes. And my first iteration, I was just hard coding, create 2 nodes here, create another 2 nodes here. And then that feels really dumb when you want to scale up and down because you have to change, you have to do a commit every time, you have to refactor a little bit. So what we're doing is it feels complicated from Puppet. From a programming perspective, it's dead simple. What we're doing is we have a list of availability zones. We are basically dividing over those to figure out how many nodes need to go in each one. And then we are flattening that hash, iterating over it, and basically striping nodes across availability zones until we run out. So it works for uneven numbers and will do the best it can. And when you scale back down, it will continue distributing them as evenly as possible. So you don't really have to think about this. This whole class is just parameterized with a number of nodes that you want. And you can bump it up, bump it down, and that's it. It's quite straightforward. This is kind of a trivial example. I'm just including it because it's a starting point for something more interesting. So our Drupal stuff needs a cron job to run, and it only needs to run on one web node. That's kind of annoying to puppetize. So I'm doing kind of a dumb hack here where we're querying for all the nodes that are classified to run Drupal in the same stage, et cetera. And the first one on the list wins. We could have more complicated scheduling criteria based on facts. So if we wanted to say that the node with the most memory or whatever gets it, or that there should be 2 nodes that get it, we could do that. In this case, the requirement was fairly simple. And so this way, if I decommission a node, I don't need to worry about whether it's like the magic node that's running the cron job, because it'll just come up on another one. The next pattern kind of generalizes. So I want to make the point any kind of an external data source, whether that's PuppetDB, LDAP, some RESTful web service that you can query, if you can write a function for it and get back an array or a hash or some kind of a data structure describing the data you're interested in, you can iterate over it. You can use map, reduce, filter, et cetera, to munge it down to the point where you can iterate over it and create resources based on those parameters. And one of the things we're doing is we're migrating between provisioning users just with a Puppet manifest and going from LDAP. So right now what we're doing is we're just purging old users via LDAP. So Zach Leslie wrote this LDAP query function. It's open source. I have a link to it at the end, that looks through for ex-Puppet persons, people tagged in LDAP. It finds a list of them, and then it iterates over that list, and it makes sure that those UIDs are ensured absent and tagged not staff. Not staff gets realized everywhere, and so when somebody leaves, their accounts get purged, and that even works, since he did some work to synchronize the UIDs, that works whether they were created in LDAP or not. He's working on it, is about to roll out a very similar pattern to create the users from LDAP. So he does a very similar query, but instead of just removing, he'll create people who are Puppet people as users and tag them with the groups that they're in. And the advantage of that over a traditional LDAP integration like SSSD is it's asynchronous. So all those users get created based on LDAP as a source of truth, But when LDAP goes down, I'm not saying it often does, but it's a point of failure, right? So if LDAP goes down, these users still exist. You can log into everything. And you can use those types or any kind of validation you want to write to validate that this is reasonable so that you don't just like purge all of your users because you screwed up, right? So that gives us basically all the benefits of LDAP auth without any of the risk. So it's a pattern I'm really looking forward to. I think he's extremely close, a week or two from rolling that out. So the commonalities here are really simple. They're all really, from a programming perspective, these are super simple, right? There's no CS interest in this whatsoever. It's a matter of you start out with some kind of a hash or array, whatever resource you're interested in, and I'm talking about resources across your whole infrastructure. And at the end of whatever path that data takes, you are creating some resources in Puppet. Or maybe you're creating a string to drop into a config file. You use in between on the path there, you're using types to make sure that at each stage of your munging that you haven't made profound mistakes and to document how that data is flowing through the system. And then you're iterating over it. You're using a reduce, maybe just a filter to process that data down to whatever the resource needs. It's quite simple when you think of it as a programming task, even though it's relatively exotic Puppet code. As a Puppet Labs employee, I feel like I do have to caution here that you're kind of taking all of the responsibility into your own hands. So you're stepping outside of some of the guardrails that you normally have. And you have to handle those edge cases. And from an organizational perspective, you kind of have to have some amount of willingness to take risks in order to be able to do more. So we've had a couple of outages that linked to use of these patterns. I think we've been able to do a lot more. We've been able to recover quickly. We can mitigate those risks once we discover them. But when you push some of those boundaries, you're probably going to have to discover that there are edge cases you hadn't thought of. And so if you're coming from a really conservative shop, it's probably worth keeping the really critical stuff as hard-coded Hira data. We have plenty of stuff that's still in Hira. And it basically works. You can throw manpower at that problem. It's not as fun, but it's the conservative approach. So I don't want to oversell this. It's an experiment. The future is really open-ended. There's a bunch of functionality that I haven't had the chance to cover here. So for example, the new language allows you to define functions in the DSL. We don't have much in the way of docs for that yet. What that basically looks like, I'm just going to bust out of this and pull up an editor. Oops. Or maybe I'm not. Huh. So the syntax for that is exactly the same as define types. Instead of define something, parameters, what it does, function something, parameters, what it does. So that presents a whole new abstraction, right? So we all know that layering define types in define types in define types, it'll get you a long ways. It'll get you a lot of technical debt, too. Especially if you start exporting them and exporting those from other ones, it gets pretty awful. Composing functions is something that the programming world has much more experience with than the existing Puppet abstraction layers. So I would ask you all to think about what your code might look like using functional composition to solve some of these problems. For example, if you want to schedule some of those resources, the way that I was scheduling either the EC2 nodes or those Drupal cron jobs, you could wrap that in a function. And you could just write a function that goes back and either returns the answers about what node that should be classified to, or about what resources should be created. Then you just run that function everywhere. And it would be simple, for example, to write a relatively straightforward container scheduler that just sort of fills buckets. You write a custom fact that says how many containers are running, say, on a given container host. You do some querying and iteration, and you create nodes based on what has capacity, or you schedule Docker job resources based on that. So there's a lot of possibility, and I'm hoping to come back in a year and say we're doing even more dramatic stuff. Another thing that I'm really looking forward to that we don't have yet is named types. So right now, you have to use types the way that I demonstrated earlier, where you list that whole long definition of a hash and what is in that hash. It will be extremely convenient once and it's a planned language feature. It's in the language spec. It just hasn't been implemented yet. If you can name that, then you can just say, I expect this function to return node definitions. I expect it to return eligible nodes, and that may be a super complex nested hash, and you don't have to read through that and grok it every time. The last thing is all the app orchestrator stuff is probably going to have fairly big changes to how roles and profiles work, because we have this application construct now. However, as far as I've seen of it, the questions of peer discovery, I haven't heard answers. So I'm planning on continuing to use these patterns, and I think that they will go really well, because the orchestrator will make all of this happen much faster. I've been just using SSH or mcollective to kick these things off, but it takes too long compared to using other service discovery tools that can kick stuff off for you. Using PuppetDB for service discovery is relatively slow. And so my hope is that the orchestrator will bring that to parity, so that you can have the level of insight that you get from PuppetDB, but not have to wait for hours for everything to run. Questions? Comments? Heckling?
I was wondering, actually, would you be interested in, could you talk a little bit more about how you test the external functions that you're using in your Puppet code, like with RSpec Puppet or Beaker?
Yeah, so using full transparency, we are not a model shop for testing everything. I wish I could come up here and say that we have magic Beaker tests that spin up every time somebody makes a PR. We don't. We have some amount of test coverage. A lot of the modules have test coverage, but it's not where I want it to be. I imagine, for my own sake, I hope that I'm not the only one here in that position. What we do have, I believe Zach's module has RSpec Puppet tests for those functions. I think Dallin's PuppetDB query has tests on those functions, and those are all in RSpec Puppet. Some of the modules that I've written have Beaker tests. Beaker is totally worth getting into. The docs are a bit confusing. It's totally worth fighting through it. What the distinction is that with RSpec Puppet, you can run all that stuff locally and fairly quickly. It's easy to run through something like Travis. Beaker actually spins up VMs and creates all of that stuff and tests whether the expected results actually happen. Both of them are valid, but RSpec Puppet is a heck of a lot quicker and more convenient to write. Any other questions? Always takes people.
Hi there. Is it possible to run Puppet like the BigQuery commands from command line?
Yes, it is. So there's a Puppet face that's I'm glad you asked, because that's something that I really like about using Puppet BigQuery, because it makes it easier while you're coding to figure out what results you're going to get back. So when you're doing exploited resource collection, ultimately, until you have committed that and run it on a node that's connected to your Puppet infrastructure, you can't actually know what results you get back. With PDBQuery, you can run verbatim the same query from a Puppet face and get back a list of results. And that, for me, that makes it much easier to plan and to conceptualize what's going to happen. Anybody interested in putting this on your own infrastructure? See what you can take down?
I have a question.
Yeah.
As you guys add more to the DSL, what about a REPL? Because quickly testing or running a little bit of Puppet code is not easy to do.
So I'm on the operations team. I don't actually write the product. I would love a REPL. And we have people from product sitting with us in operations, and we tell them that we would love a REPL. So I don't know about any plans to add a better REPL. I think it would be a really good feature. If you all make a lot of noise about wanting a REPL, it will add to, it'll increase the priority of that. But, it's something I would love to have. I don't know of any plans for it. Yeah, like really, the people in product, the people in engineering, they really care what people think. And they listen to us, but they listen to all of you as well. And if they just hear it from their own ops team, they don't really know, is it just some far out thing that we're doing that's at the edge of something, or is there a general interest, and this is something that all Puppet users really want? So if there's something you want, please make yourself visible. Even if you end up filing duplicate tickets, if those get closed down, the people notice when enough people ask for it. All right, I don't see any more hands, but I don't see very much at all because
You have a question.
Oh, cool.
When your examples for making sure that there are enough nodes in a quorum before actually setting anything up,
Yeah.
does that increase to consistency, slow anything down, or does it become annoying at any point?
Can you clarify there? What are you imagining that's slowing down?
I'm imagining that you'd need multiple Puppet runs in order for the service to actually get set up, because you need to run Puppet for
Yep.
for the facts to get defined, for all of the
Yep.
things this needs to be included to get defined,
Yep.
and then run it again in order to
Yep.
actually set it up.
Absolutely. So during the keynote, Luke talked about being aware of the need for Puppet runs and eventual consistency in a lot of use cases, and considering that a bug. I think it's a bug too, but it's a bug that I'm willing to live with because it makes my life easier. So The totally heinous hack that I have for that is when we bootstrap nodes in EC2, there's the cloud init script runs Puppet 10 times, and it uses an exponential backoff between them. So when I need to provision stuff, it runs through. It always succeeds eventually. Sometimes it takes 3 runs. Sometimes it takes 7 or 8. I don't like that either, but it solves my problem, and I don't know what to do about it. The only good option would be to define everything ahead of time, and that moves the work from the machine to me, and I'd rather have the machine run a bunch of pointless Puppet runs while I'm out to lunch than for me to have to make a bunch of changes to Hira data, because that takes away from my pinball time.